So, guys, it's another day. Actually, it's not a bad day. And today I have a guest with me. He goes by Evans Nartey. He's basically created a new product, right? A product that a friend of mine linked me to on LinkedIn. Shout out to someone for doing that. And taking a look and speaking with Evans on the products, I become more interested in it, and I thought it best that I put it out there for people to know more about what it is. And so for the next few minutes, I'll bring on Evans and then we'll chat about his product that he has, that he's creating for the market, and which would be beneficial to people, and so that we don't spend money and focus only on concrete blocks, concrete blocks. There are other materials that are there that we can use to build. And so without much ado, let me first welcome Evans onto the show. So welcome, Evans. Thank you for giving me your time to talk to you about whatever you are creating and for sharing whatever you've done to the world. But to get the ball rolling, I want to first start off with your origin story. I want to first start off with how you came into doing this. What is the origin story of creating this product that you have? Why did you jump into it?
Yeah, that's a very good question. And this started as an idea back in when I was in K University as a student, and I was reading geological engineering, which basically is about exploring the earth for materials, resources. So most of the things in geological engineering, we learn a lot about gold exploration, material exploration, oil exploration. And I think back in second year, there was a topic that we took a topic which was on mineralogy. And there's one thing about it that really struck me. That was a mineral called feldspar, which I didn't quite understand it so, but then to me it seemed like the mineral had more to do than what we think of it. That was really the impression I had of it, because it's literally the most abundant material in the earth crust. Like literally 60 to 80% of the earth crust beneath our feet are feldspar materials. So that struck me as, is there something more to that material than it meets the eye? And so I started doing more deep research about it on my own. That was back in second year. And it turns out it's just an aluminum silicate material, which is a kind of material that people have used to develop a different kind of concrete called geopolymer concrete. So the name geo means earth, and then polymer means many forms. So basically someone had developed geopolymer concrete, but then they used something called fly ash. And fly ash is basically an aluminum silicate. And so there and then I realized, if fly ash is a base for making this kind of material, and then it's something that is not available in Ghana. I mean, it's very difficult to come by in Africa as a whole. But then feldspar is something which is really abundant, and then they have the same chemistry. Is it possible to kind of turn that to make concrete? That was a question I asked myself. And so you realize that the question wasn't about how are we cutting emissions. No, it came from how are we creating abundance? Because I realized from my study, that's like a very abundant material. So how are we using that to create abundance for people? And simultaneously around that time, my late mom wasn't really having a good place to stay. I mean, because she had come from a divorce, and so in my mind, I was like, whenever I'm done with school, I'll really try and build my mom a home as soon as possible. Also considering the fact that my daddy is a building constructor, so I've been very familiar with building and the building process right from junior high school. And so there were a lot of multifaceted things going on, combined with the my studies and also discovering about geopolymer concrete. So it was very evident to me that when I'm done with school, I'm definitely going to kind of bridge or bring this stuff together. The experience I have, the fact that there's a need to fill, and then also the knowledge I've gained. And so from second year to completing school, I spent a lot of time on studying these geopolymer materials, but then those were just theory stuff. And then it wasn't really part of our academic study. This was something I was doing outside of my academic study. So right after school, or let me say, getting closer to ending school, I spoke to one friend in my class who is called Gertrude, and I kind of told her what I've been thinking of for the past few years. And she was like, "This is very good. She would want to join." And so Gertrude became my co-founder to developing geopolymer concrete. And then I had a very good friend from back in primary. He's called Emmanuel Frempong, a very smart guy. But then he went to school in Morocco. He was studying electrical engineering in Morocco at the time. So I've known him for a very long time. And I actually told him, yo, this is what I want to do. And I know you are very smart. So we can do this together. So Gertrude, myself, and Frempong became one team to see how possible we can develop geopolymer concrete. And as I mentioned earlier, you can't get fly ash to make geopolymer concrete in Ghana, and that's the base material people have developed geopolymer concrete on without cement. And so we knew that if we want to build or replicate that, we have to ship that in. So we had to ship fly ash from China to develop prototypes and see how that would work out. And honestly, we tried that and it wasn't working. It took us from 2020, after school in 2021 and early 2022, we had to sample out materials. We tried using slugs. We went to source slugs from Tema. It didn't work out properly. Then we kept doing that, and I think early 2023. So you could see from late 2021 through 2022 to early 2023, somewhere in February, that's where we had first working samples, like being strong and actual working like concrete. And that's where we had a strong geopolymer concrete based on already established geopolymer concrete techniques. And so that was like a huge step because now we have a benchmark to compare our original idea, which is the feldspar-based geopolymer concrete to. And so there was a big gap we had to bring. We had to build a machine because you'd want to break down the feldspars down to extremely fine particle sizes. So we didn't have the equipment to do that. However, the idea was working. And so what we did is we applied to the African Climate Innovation Challenge in 2023 after our samples began to work. And I think somewhere March, April 2023. And we happened to be part of the top 5 best teams, I think top 7 best teams for the African Climate Innovation Challenge through the development we've done. And so when we were part of the top 5 winners, we were able to get a grant. And that grant directly went into building an equipment that could break down the feldspars I had mentioned earlier to desirable particle size to test that to make the geopolymer concrete without the fly ash. Okay. So we are developing on the fly ash, which we know it's not available in Ghana, but then we know the chemistry of the fly ash is the same as feldspar, but then quite different. So you have to kind of develop or iterate on that. So we built a machine and we started iterating.
So let me sorry to cut you, but let me ask, what is the main differences between the feldspar and then the fly ash? I know there might be similarities in creating the geopolymer concrete, as you said, but
yeah. So one key difference between the feldspars and the fly ash is the chemistry. Feldspars are crystalline materials, and then fly ash are amorphous materials. So I mean, crystalline materials means they are crystalline. They are kind of like crystals, and amorphous is more like they are pulverized.
All right.
And so they are highly reactive than the feldspar, but then they are all the same aluminum silicate materials. So what you want to do is to find a way to turn the crystalline material to kind of amorphous or make them reactive. And then you could use mechanical equipment to do that. So that's what we built. And so we built that in 2024 because we were part of the winners of the African Climate Innovation Challenge late 2023. So as soon as we had the grants, that was the first thing we built, test it out. So we're testing 2 things, testing scalability and testing the feasibility, which worked out so well. And that has been our breakthrough since 2024. We've got on to win several awards afterwards, and we are currently part of an investment accelerator to scale up the production. And one of the things that we kind of did so well is product market fit, which is we are not just making the geopolymer concrete, we're actually turning the concrete into interlocking blocks because we understand the problem in the built environment. It's not just about the emission, it's about how we build, how are we making it faster, how are we making it less expensive. And if you bring together design principles like modular construction and making the process much more familiar, people can adopt to the technology. So like more like a thoughtful design process beyond just the material science to approach the problem in the built environment. And also considering the fact that we need to build a lot of homes, because a huge part of my story on doing this was because I really wanted to build a home for my mom someday, which didn't happen. But then that gap is really huge. Millions of people lack home. So if you bring in the material science, the fact that these materials are highly abundant, and also bring in design principles like interlocking design and those kind of design philosophies, combined with architecture, you can really create amazing products. So yeah, that's how the journey has been like so far.
Yeah, that's cool because I love the inspiration behind looking into the material and into building houses that are affordable for people. So, is this how Theseus development started? Did it start when the three of you, Gertrude and Emmanuel, you brought them together and then started focusing on geopolymer as a,
Yeah,
and so with that, you've gone on to create a product fit for market, which you can scale and take us through how you're able to achieve its feasibility, and when you say the scalability of the products that you've created.
yeah. So how we went through the process is that we didn't actually register the company first of when we thought of the idea. No, it was iterative, highly iterative. And I remember there was a time Gertrude and I were we were kind of doing sampling at Gertrude's place at Ablekuma. And then the samples weren't working out. Really wasn't working. We kept trying, it wasn't working out. And that was way before we even registered this as a company or something, registered TCL development as a company. So it was through really rigorous iterative process. And when it wasn't working, I kind of had to stay on my own for some time and go through the chemistry again, review it. And one of the breakthroughs was actually from Twitter. Okay, so I shared a post on Twitter about our materials not working, and then I had experts commenting and saying, "Okay, you could do this, you could try this." So it paid detailed attention to the inputs I treated, and it worked. On my own in 2022. I think I had probably treated on geopolymers over 50 times, creating a sample, redoing. So I don't know if I've showed you a sample block before, but then those round samples.
You have.
So yeah, so I create that one, look at the strength, crash it, see it, redo it again. A lot of times, like I used to work at Solar Taxi, an electrical car company back then. So mostly on the weekends or at night when I come back from work, I kind of create a sample quickly, write it down that I use these ratios to create, then I test it. So just trying to find the balance. And so it took a lot of iteration, and even up to now, I still kind of do the iteration. I think 2 weeks ago, when you mentioned that we should have this meeting, I mentioned I have some people coming over. Yeah, so that weekend, some friends came over because they are thinking of using geopolymers with color pigments to create flower pots and stuff. So I got them over to come so that we kind of do the sampling together. So for the first time, we hadn't done colored geopolymers. So when they came over, we kind of created samples with color based, making the geopolymer colored like different colors, not just like the raw concrete color. And so the iterative process still works. I feel like, and I do know for sure, even when we build a full scale production facility, the iteration on pushing the boundaries of making the concrete better, improving the technology will still be like a core philosophy when building this brand. So how we got here is actually through making, breaking, repeating, like the cycle of kind of iterating on it. And that's because this is a material you need to really be get certain things right. And how are we looking at scaling? And I mentioned that we are part of an investment accelerator, which is called the Third Derivative. It's one of the world's biggest climate tech accelerators in the world. The goal is to secure pre-seed funding to bring together all we've learned so we can de-risk the technology at scale. And scalability also means, do we know how to produce at scale? And then that's one of the biggest challenges that we've tried to overcome, which is understanding that we need this equipment to break materials down to these particle sizes, add these ratios, and get the materials to work. That's it's kind of let's say completely figured out. And so and that was a huge reason why we're able to join the accelerator. So we've kind of we don't have any basic science risk in our process currently. And so there's in climate tech or deep technology, there's something called a technology readiness level, which classifies the readiness of a technology for markets. And given that we've done a lot of lab testing, we've done a lot of crash testing and iterative testing, this kind of puts our products around like technology readiness level of like level 5. It's a scale of from 0 to 9. So we're on like the level 5 of that chart. And so which is more like we've done a lot of in-house testing to validate if the material actually works. So currently what we want to do is to de-risk the production. So once we're able to close our pre-seed funded round, we already have letters of intent from individuals and builders who want to kind of use the product to build. And so these are people that we want to convert those letters of intent into pilot projects. So if let's say you have a project you want to build, I think the last one actually mentioned that if you have a project you want to build, we can actually talk about it.
Yeah.
And yeah, we get that running. When we have our production facility, we get that running and build a pilot project. Maybe if it's like an individual single family homes or something. So yeah, this is more like a call to action to bring together a lot of developers and builders alike to kind of adopt to this technology. And I think it's going to be great. And yeah, for me, I look forward to more and more advancement when it comes to deep technology stuff like this. And I feel like Africans, we've really lagged on that part. Usually, we find it very difficult to, because geopolymer is like a new frontier material science to combat emissions by the cement. And there are very, very few companies or teams in Africa trying to really build these hard technology stuff. And yeah, what we want to achieve also is to kind of inspire people to build difficult products like these ones. Yeah,
That's great. When we started, you made mention of creating the geopolymer concrete into blocks, into interlocking blocks. Now, when I first chanced upon you, that was what actually piqued my interest, right? So I want you to be able to tell us why do you go into creating interlocking blocks with the geopolymer concrete, and how is that going to further enhance the affordability of homes and building to a scale where would not only depend on concrete blocks or concrete blocks, but would have the opportunity to use your product and then other products as well that would really help the building industry to grow and maybe reduce the amount of cost that we are facing when it comes to building in the country.
yeah, that's a very good question, and I think there's been a lot of thoughts actually went into the interlocking design. It started from the interlocking design didn't start as the original product we wanted to come up with. The original product we wanted to come up with was just the geopolymer concrete. So we didn't really think of would it be molded into precast, or we didn't think about that until I became an edge expert in 20. So until I actually learned about edge before becoming an edge, that was in late 2022. And one of the key things about edge is energy, materials, water.
Yeah.
And because of what I was doing, materials was my interest. And the goal of edge is actually to find measures to reduce energy, reduce materials, and reduce water. So it is about reduction and saving. So on the edge platform, you are looking at your savings on materials, on energy, on water. In that case, then that's when I actually realized, then if we do geopolymer concrete and then people keep building like the way they build, we are not going to save materials, technically, yeah. Because I mean, then if you are just doing the same block work, the same plastering, yeah, it's still the same materials, the same quantity of materials you are using. So that's why I began to consider, could we find a way to reduce the materials to meet those kind of standards? And yeah, there were a lot of alternatives on the market. There's modular construction, like the one that you would precast the entire building. modular. You don't have to do the block work on site and stuff.
Yeah.
There's 3D printing. But then when the moment you consider that if you are really wanting to tackle a problem for a market like Ghana, you should also rethink it, because would people really use 3D printers to build homes in Ghana? Maybe not, because first of all, the 3D printer itself is very difficult to. It's very expensive.
Yeah.
It's
So
very expensive. Yeah, very expensive. First of all, it's very expensive. Modular construction has been there since like I think 1970s. It's not like a new technology. It's been there, but then why hasn't it been adopted like the way it's supposed to be adopted? And it all comes down to design. Okay, there's one principle in design that says that if something is too advanced, people wouldn't want to adopt. So it should be like advanced and also acceptable. So you should kind of have a balance between I'm coming up with something very new, also the thing feels familiar. And so the best way we thought of doing it was look at the traditional blocks we have on the market and then make that modular. And so the same dimensions of the 450 by 450 by 225 by 150 dimension for a standard block. You've just taken that and turn that into interlocking. And what that does is it reduces extra plashing and also reduces extra mortar joint. So technically, you can just stack up the blocks, have the structural tie inside the corners, and then you can paint the walls directly by maybe using some fillers on the tiny, tiny joints in it. So you don't need extra plastering. That reduces materials and costs because that reduces labor. And so the moment I thought about that design, I shared with my team, like, okay, we can actually test this and see how that would work, especially what do you think about the building professionals like builders? So I actually talk with traditional masons, okay, on site and actually have 3D models of it, show it to them. They're like, yeah, this looks like very handy. Okay, it's very handy. It's not like so huge because there are people who do wall panels, concrete wall panels, but then a traditional mason would find it difficult to handle those materials because, and considering the fact that we are in Ghana, people don't hardly would hire a company to build their normal home for them. They'll get a mason to do that. So
that's true.
considering that market, you have to think of that. And I think about these things because my daddy is a builder, and my daddy actually got into the construction industry through informal work process. My daddy started as a mason before becoming a contractor. So those deep questions are like very intuitive for me. And another consideration was the fact that the labor in construction is actually declining. And especially when it comes to the masons, the carpenters, the steel benders, it's really declined very sharply. As I mentioned, my daddy was started as a mason. I asked him, when you were training for being a mason, how many were you guys? He was like, they were like 11. And I asked him, for the past 25 years, who have you trained? The answer is 0. Right. And then why is that? The reason is because it's very difficult to labor on site is very difficult. If you've been on construction site, you see the laborers carrying the blocks, doing the mortar joints, it's tedious work. So young people would rather want to do boats and Uber, Okada, exactly done because that's like the gig economy.
Yeah.
Okay, so if you think of a product like our own, which is trying to reduce the labor and make it more easier to handle, what that does is it kind of strengthens the construction labor force again. Okay, so it kind of becomes like the gig economy of transport, just like the way people don't do taxi again, but then they will do Uber because it's like a flex. It's nice. The same thing here. We are kind of bringing in the gig economy mindset into the construction industry. So exactly. So a lot of design consideration, looking at the people, considering the materials, also considering how to handle the materials and the markets that we exist in. That's what came out. That's how the thought process of the interlocking design came about. So yeah, I know for sure once we pilot production, there'll still be the gap to fine tune the design. Yes, for sure. But then the starting point was actually from a very thoughtful process.
Yeah. So you showed the model, the basic model to some amazing. They thought it was usable and it would be helpful to them. Now, the current material we all use, the blocks, most of them are hollow blocks. Is yours also going to be hollow as well, because you know how we can also cut down on so many things in, as you said, the edge, in the use of materials. And I know having hollow materials really boosts up the embodied energy usage of the material
Yeah.
and how effective it is in creating a really sustainable building. So is yours also falling in line with that aspect of hollow interlocking blocks, or it's not?
Yeah, it's actually hollow in design. It's actually
Okay.
hollow.
All right.
And hollow because we need it to be lightweight so you can handle it easier. And also, I think hollow design kind of helps with energy efficiency. Yeah, I think that's one key thing about hollow materials. I
Mm.
mean, you can go far and say, okay, if it's hollow, then you can put in insulating materials into it. That's when you are kind of in a very hot environment and you want to kind of save more energy. So it kind of makes it more easier to bring in, because I think traditionally when you are doing the wall insulation, the wall would be there, then you put the insulation blankets on the wall. Maybe with our interlocking design, you can put them in the hollow spaces, and that would make it more minimal. So yeah, it's actually hollow in design. Yeah.
Okay, that's cool. So speaking of, so it's being hollow. What would be the benefits to, um, as you said, any normal person who's looking to build, because they might not build with a contractor or a builder elsewhere? Why would somebody look to use your product over the normal one that we use now, like in the future?
Yeah. Cost wise, one cost. So considering the fact that you are reducing materials and labor, that would bring down the cost of construction process down to like 25%. But then the question actually goes deep into what's our business model would be like to deploy the material. And so the current goal we have is to be able to close our pre-seed funding so we can build a production facility, which will deploy the blocks directly ourselves. However, we are not going to scale by building new factories on our own. No, that wouldn't be scalable. What we'll do is once we're able to de-risk the technology by our first pilot production facility, we will scale through already existing and kind of look at how we can scale through already existing block factories. So maybe just make a few changes on the production system they have, then supply them with the raw materials we produce, then they can deploy that. So that would make it much more cheaper because now we've been able to, when we are able to achieve decentralized production through already existing systems, that would make it much more cheaper. So yeah, it's a business model consideration as well. The question is asked to see how we can scale and reduce the cost of production and stuff like that. So yeah, huge consideration and very very huge consideration and more strategic thinking to come to play. But for now, what I know we can't do and control is be able to build a production facility and deploy the product ourselves. But then for sure, we can't do that to scale. We have to find different strategies to scale. Yeah, that would help reduce the cost.
Yeah, yeah. I think that would be a great benefit to future builders, future homeowners who are looking to create their own building. But let's look at another aspect of it, right? Why would somebody choose your product in terms is what's the strength of the materials compared to any other material on the market?
Okay, so we developed the moment we realized we wanted to do interlocking blocks, we focused on the strength of the blocks um, on the traditional concrete blocks.
Mhm.
Actually, geopolymers are really tough materials, and people are creating geopolymers outside the country for sea defense walls and ultra high performance concrete. But when we developed our product to fit into the housing development market, we don't need that UHPC strength for the blocks. We need something around. I think on the Ghana Standards Authority, we bought the standards a couple of months ago, and in the Ghana Standards Authority standard states it should be the highest class is like 4 megapascals, and some of our materials are like 10 megapascals and over. So in-house testing we have like 10 megapascals, and I think in this month in August to early September we'll be running a full test with the Ghana Standards Authority. So we'll release the results out for people to see
Okay.
the values from GSE. And that's what I'm currently working on to create the samples and take them to the Ghana Standards Authority. I mean, for
That's
in-house testing, we've had like 10 megapascals and over. So yeah, we look forward to see the results we get from GSE. So yeah, and
yeah.
that's also a step towards product certification. We want to certify this product. Yeah. And so yeah, when it comes to strength, it's actually head on with the traditional concrete. And I'm hoping to meet you soon so that I give you a sample. You see how it feels. It feels just like the normal concrete. The only difference is there's no cement in it. So the way it feels, the way it looks, just like normal concrete. The strength, very competitive with concrete. So yeah, the only thing is reducing cutting off cement. Yeah.
That's good. That's good. Honestly, I also really like to see it. I mean, and hold
Yeah.
it in my hand to really get a feel for it.
Yeah.
But since you're an edge expert, I would want to ask you this. I'm not sure about that though, but you know, would there be a time where maybe your product will be listed on the Edge app in the Edge software, or it already is? You can
Yeah.
speak on that.
Yeah, that's a very strategic question, and yeah, definitely something we've considered. And um, at the Ghana Green Building Summit in April, um, I kind of met with Paul Okra. Paul is like, I think he's the lead for Edge in Ghana.
Yeah.
Yeah, I think Paul. Yeah. So I met when the first question Paul asked me was, "What are the E values for our concrete?" And then I answered, "We don't know the E values yet." But then one of our co-founders, Emmanuel, when he was doing his masters in the UK, his study was on the thermal conductivity of geopolymer materials for renewable energy storage, which shows that geopolymers have significantly low thermal conductivity, which means you save energy when you use such a material. But then we've not yet done like actual E values. And so I think the first step is to get the products being certified, like something like GSA, Ghana Standards Authority certifying the product first. Then from there we can do those detailed figure out those numbers to be able to align with the Edge standards to deploy that on the Edge platform. And I actually did have this conversation with Dennis. Dennis passed away I think a year ago. So I met him in Kenya in 2023, and
Yeah.
then I showed him the geopolymer sample, and he was like, "This is really cool. I should find some time and come over." So we have more chat about it, but I mean we never did. So it's really something I would really consider in the future.
It's unfortunate that that happened. It would have been great for him
Yeah, yeah,
to have a feel of it,
yeah.
and we'll push it for it. But I think we're almost up with time. But I want to ask you almost one last thing. What is the next step for Geopolymer Interlocking Blocks and thesis development? And I know right now you're in the pre-seed funding, and so what should we be looking forward to when it comes to everything regarding your products?
So yeah, the next step to look forward is we kind of build a production facility very soon, very, very soon. That's like the next milestone we want to achieve. And that would be big. And after that, it would be full of speed. There would be a lot of speed and we'll really get up to speed once the production facility is built. And I think it would really define what scaling really means when it comes to deep technologies, because for the past 3 years, the focus has been on how can we really scale this product. And yeah, both in terms of the economics, in terms of the material strength, in terms of the people who want to use the material, like how can we really scale, like driving force to scale this product. So once the production facility is being built, which is our key milestone right now, we'll be up to speed here. So let's project and say we'll see a lot of geopolymer homes in the decade to come. There would be a lot of that to come.
Hopefully, by that time, most people would have bought into it. Most people would have started using
Yeah,
it.
yeah,
Even now, we probably
yeah,
would have started using it to see how exactly we can
yeah,
build with it, and then even work out the kinks on site as well, to
yeah,
really move away from always blocks. We can have other blocks, the interlocking blocks, as well as rammed earth and all those other materials that
yeah,
should
yeah.
be used by people instead of always depending on the
It's
concrete
amazing.
blocks and the cement and all those things. Reduce our cement content. We can also be able to reduce our carbon emissions. So
Yeah.
actually, this is the end. But I just want to say thank you for coming on. Thank you for expanding our knowledge on whatever you're doing. And I hope, and I'm sure a lot of people will hope that we get to get the facility moving quickly and then get a production on the road so that geopolymer interlocking blocks can be big in the near future.